Hi everyone. Today I'm going to talk about a problem that has been going on social media, and it's kind of difficult to solve, and actually it is a difficult problem to solve. Let's start. The problem is there is a rectangle and there is a semicircle inside the rectangle, and then we have the diagonal. What is the area of the shaded part? The way that I propose is, if I get the area of this right triangle, and subtract this part, this blue part, and then if I subtract this red part, I will get this shaded area that I want. So this is pretty easy. That's just a 4 by 2. So that's 4 by 2, which is 4 times 2 divided by 2, well, it's 4. That was pretty straightforward. I prepared the answer, so I don't need a calculator. It's much easier. This one is also not difficult. If you divide this rectangle into 2 squares, so you have a square, and then I have sector of area of a sector, which is 1/4 of a sector because of this 90°. So I can find this area and subtract this area from the square. Then I get the part that I need. That's a square, 2 by 2, so that's 4 minus, and that's 1/4 of a circle with radius 2 times pi. So that is 4 minus pi, which is 0.858. So let's write it here. So far, so good. It's not really difficult. Here comes the difficult part. How can I get this part? Well, to find that, we have to go through a lot of trouble. I look at this part and this part and this part. So we have these two. That's a sector again with this angle. Now, how to find the area of this sector? I need to find this angle, but again, difficult to find this angle at first. I'll try to find this angle. Since this is isosceles triangle, so I can assume that this is the same degree, same measure, then I can find the angle that I want. So let's do that. If you look at this right triangle, and we call this angle theta, that is 4 and 2. So I have the opposite and the adjacent. So if I want to find the angle theta, I get tangent inverse of 2/4, which is about 26.565 degrees. So I've got this angle theta, isosceles triangles, I get the angle 2, so I can find, let's call this angle alpha. So alpha should be around 126.870 degrees. Now, we're here, we want to find this area. So I've got a sector with this angle 126.87. So the area of that is 126.87 out of 360 of a circle with radius 2 times pi, which is 4.429. Now, I need to find the area of the triangle, the isosceles triangle, and subtract from this circle. I get the part that I need to find the answer for the question. This is the isosceles triangle, and I know that this is 26.565, and I have this one. To find the area of this triangle, if I use this formula, half of A times B times sine theta. You know, if you have the triangle, you have this side, and the angle between them, the included angle, you can find the area. So I'm going to use this formula, but I don't have this base. I don't have B. So I will use law of cosine. I will use law of cosine, which is a squared plus b squared minus 2ab cosine theta. Something like that. Because I've got this side, and I have the included angle. So if you use law of cosine, we can find the side opposite the angle. So let's put the numbers here. So I get root of 2 squared plus 2 squared minus 2 times 2 times 2 cosine of, and I've got this angle already, which was the angle alpha, 126.87. That is 3.578, which is this base of this triangle. Now I put that number plus 2, punch it into this formula, and I get the area of the triangle. And the area of the triangle is half of 2 times 3.578 times sine 26.565, which is 1.342. That's the area of this triangle. Now, we had the sector minus the triangle, this one, I get this, which is 3.087. Done. Now, 4 minus 0.858 minus 3.087 is our answer, which is I haven't written it down here, but that's about 0.05 as I remember. Should be something like that. 4 minus 0.858 minus 3.087, and that gives us the shaded area. If you have a better way to solve this evil problem, this difficult, challenging problem, please do share it with us. Thank you very much.